So after understanding how to use the monitor and also how to use the monitor to debug your system, we're gonna use the monitor to actually look into how to use a ADC system, or how to apply into the ADC system if you're taking in the analog readings. Alright, so over here you have a button, alright, which is grounded, okay, and you have a VDD, alright, and this VDD is connected to a resistors and towards your digital in, alright, while your button over here is connected into the analog pin, alright, and also towards the digital pin also, okay. So you want to compare between the analog and the digital, okay. So this is so the analog and this thing are your microcontroller, alright. This is microcontroller, alright. So your Arduino itself has an analog and digital in, so you connect your button into an analog and a digital, and then you compare how the thing actually works, because we are actually looking into investigating the switch bouncing. If you still remember your switch bouncing, normally when you press the button, alright, you actually go like this, but however, due to realistic stuff, alright, you may actually have certain bouncing that may occur within here, or that may actually distort your reading of a button, or for some reason sometimes it spikes up and then it may actually come like that. So you want it to be like this, alright, correct, but however sometimes the spikes itself is higher than your button, such that it thinks that you continue to press high and it continues to be like this. Alright, so that's the problem with the bounce switch. Alright, so we are trying to look at the thing while we can compare using an analog and a digital system. So the VDD is actually your power supply. So in some sense, you're actually supplying the power, alright, to your button also, I think. I don't know. Alright, but anyway, in this portion over here that we're doing, we aren't looking at a pull up thing. Alright, we didn't actually have a, if you still remember, you have the input pull out. Alright, so we're actually not using this. Alright, we're actually using a resistor, alright, to replace this pull up resistor, or the so for this reason we do not use the built-in pull up resistor, as you can see. Alright, so they actually use a resistors over here, alright, not to actually spoil your button and things like that. So over here this resistor is somewhat about 2 kilo ohm, since this is the input impedance to the ADC. Alright, I think the resistor itself is trying to protect the ADC processors, things like that. I don't know, leave you to think about it. I think because he also never say anything about it. But anyway, so you can easily set up the problem by actually having the analog read resolution 12. Alright, this 12 means that it's 12 bit, alright, which is 2 to the power of 12, which is 4096 possibilities, or 4096 bits lah. Alright, so therefore at first you need to write analog read. Alright, the function is to read the data from your analog pin. Okay, so this is the ADC pin, which is, if you look at your Arduino, so in your Arduino you also actually have a analog in, so you actually have A0 to A5 of the pin. Alright, so you connect the analog wire into here, and then you connect to your button. Alright, so if you still remember, your button is actually connected to another digital pin, so you're gonna connect this to another wire. Maybe you can connect to any of the pin 1, pin 2, whatever you want. Okay, so the button is connected to the digital over here and to the analog. Alright, so you actually compare between the analog and the digital, I think. But anyway, then you may read is A0 to A12. Alright, this A0 to A12 is actually for the Arduino v9e2. Alright, what I show you in the picture is Arduino Uno. Alright, which is another picture. Alright, this is Uno. Alright, so it's another device, but it's the same system lah. Alright, firstly you need to initialize your analog read resolution as 12, so you'll read your resolution in terms of a pretty with 12 bit, which is a average reading speed for your Arduino. Alright, so Arduino normally you use 12 bit, or you can use 10 bit also can. But anyway, next you initialize your pin, your ADC pin, as equals to 0. So you tell the system that over at this side, alright, so I actually connect it to pin 0. Alright, sorry, connect to pin 0A0. So this according to my button. So this is how it is trying to say lah. Alright, so initially your pin is equals to 0. So input value is equals to, you read your pin, your pin is actually pin 0. Alright, so you read the voltage on the pin. Alright, of course it returns an integer, and we have 0 volts gives a reading of 0. 3.3 volt, it will give you 495. Alright, 495 bits. Alright, because this is 4096. Alright, 2 to the power of 12 is equals to 4096 minus 1. So you have 4095. Okay, so therefore if you read, for example, if you read 1.75 volt, alright, then it's taking, is it 1.75? 3.3 divided by 2 is actually sorry, is 1.65 volt. So for at 1.65 volt, alright, you have about 2047 beats. Alright, so if you were to just take a look, over here you have 0 bits, over here you have 4095 because it's a 2 to the power of 12. Alright, so therefore in between, which is happen that you want to have 1.6 volt or 1.65 volt, you have about approximately 2045 like this, or 2047. Alright, so if you want something like 1.1 volt, you just take 1.1 volt divided by 3.3 volt, multiply by your whatever voltage, which is in this case 3.3. Alright, 3.3 volt. So you take your input, your whatever input voltage that you want, divided by the maximum voltage that you can supply. Sorry, I should have said correct. So you take your whatever voltage and then divided by the maximum voltage that you can have, and then multiply with your number of bits. Alright, so if you were to do that, you have about 1228 lah. Okay, so over here you have 1228. Alright, so different voltage it can be represented by different number of bits. Alright, so this is how it's being worked out lah. Alright, this is what we set up. All these codes are what we set up in order to read the analog. Right, because we already read analog, read your whatever pin. So once you read already, you want to print, right? So you need to serial dot print line whatever thing that you read. Alright, and you keep on looping, right? So you read already, you print, and then you loop back to reading again, and then you print a new analog value. So for example, you read, you receive 1, and then you print to the serial monitor, say that I've received 1 analog signal. Alright, and the next time, so you go back again, you read, alright, you read a second value, and then you send to the serial monitor, this is the second value, and then you go back, and then you read another value, and then you send back to the serial monitor. Alright, so you keep on sending to the serial monitor, and you keep on reading the analog signal. So this thing reads and this thing prints, so you keep on looping and looping and looping. So this is how you normally would want to print your analog system. Alright, this is how we actually read analog system and actually print out the data. But however, this is actually a problem. So this problem I shall discuss in the next video, and my purpose over here is just to only introduce you with how can we use the monitor to actually help you to look at ADC system. Alright, so therefore I'll share with you what we know for the problems that may arise from this method of reading your analog system. Alright, so I shall see you there.